Okay, so we've talked about how to use a sign chart. There are a couple of videos on Google Classroom to help you with that if you haven't seen those yet. Now let's talk about how to make a sign chart. And what we need to do to begin with is we need to actually find the x-intercepts. So for all the problems you have on Delta Math, the hard part has kind of been done for you. You're always going to be given a factored function on the problems I've given you. So that makes things a little bit easier. Because remember, if we want to find the x-intercepts from a factored function, all we need to do is take each of our linear factors and set them equal to 0 and solve. Right? So when I say linear factor, I mean each of the expressions inside parentheses. So in this case, we have 1, 2, 3, 4 linear factors, meaning we're going to find 4 x-intercepts, and we're going to start by marking them on our number line here, our x-axis. Okay, and I'm going to skip some steps because I hope that at this point you know how to find the x-intercepts, right? But we see from our first linear factor, we get an x-intercept where x is -1 and y is 0, right? From our second factor, notice that's a little bit tricky. It's a 2x plus 8, not a 1x plus 8. So if we solve, right, ultimately we're going to find that 2x is equal to -8 and x is equal to -4. So our solution here is -4, meaning we have an intercept where x is -4 and y is 0. Third factor tells us our third intercept. Fourth factor tells us our fourth intercept. And now we have 4 points that we can plot on the number line. So where x is -1, I mark that, -4, -6, and +2. These are my x-intercepts. So I'm done with the first step, so we hit done. Now, what we need to do is we need to look in each zone that those intercepts break the axis into, right? So now we've got kind of 5 zones, and we want to check to see what the sign of the function is in each of those zones, right? And here's what we're going to do. We're going to use something called test points. And those test points are exactly what they sound like. We are picking different numbers to plug into this function, right? We're picking the easiest numbers that we can possibly work with, and we're going to see how those numbers come out when we plug them into the function equation, right? So what numbers are we going to choose? We're going to choose a number on the x-axis in each one of the zones that we have to explore, right? And let's start from the left and work our way across. So if I'm interested in figuring out the sign of this first zone right here, meaning where is my function to the left of -6 on the x-axis? All that I want to do is I want to take any x value in this zone and plug it into my function equation. And all we care about is the sign of the answer. This is something you can plug into a calculator, or there are other ways for you to think about it. But let's do an example, right? I want to keep this number as small as possible so that this calculation is nice and easy. So let's look at the smallest number we have here, which in this case is -7. So in other words, we're going to take x equals -7 and plug it into the function, right? So we have our function equation. What are we doing? We're taking that function equation and we are going to plug -7 in the place of x. All right, so what do we have? We get f of, -7 is going to be equal to -7 plus 1 times 2 times -7 plus 8 times -7 minus 2 times -7 plus 6. Okay. Again, this is something that we can plug into a calculator and work out that way. Right? We may get really big numbers here. We don't need to know what those numbers are. All we need to know is the sign. Right? And once we get the sign of this answer, right, whether it is positive or negative, that's going to tell us whether the function is positive or negative in this zone. But again, all we're doing, we're taking numbers, plugging them in to make the types of sign charts we used in the previous problem.